Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA ECET Coaching Center, Koti, Hyderabad. In the previous video lecture, we discussed about a few questions from the chapter of physics, heat and thermodynamics. The topic which we are discussing about is thermodynamic processes. Because by analyzing the PYQs of ECET examination questions, what we have found that the maximum questions are appearing from the very topic heat and thermodynamic processes. So part 1 video lecture is already updated. This is the part 2 we are discussing about. Okay, well, let's move on to the questions of previous ECET questions. Then I'll at the end I'll be giving you the most important questions too. Question number 1. During an adiabatic operation, the pressure and density of diatomic gas is given as density ratio, pressure ratio, and gamma value is given as 7/5. Asked the question is pressure ratio is what? We know in the adiabatic process pressure ratio P2 by P1 is equals to V1 divided by V2 whole to the power of gamma. That can be written in terms of density D2 divided by D1 whole to the power of gamma. The density ratio is given as 243. 243 whole to the power of gamma, gamma is 7/5. You know 243 is 3 to the power of 5. 3 to the power of 5 whole to the power of 7/5. You see 3 3s are 9, 9 9s are 81 and 81 3 times, 3 1s are 3, 3 8s are 24. So 243 can be written as 3 to the power of 5. This 5 gets cancelled, the answer is 3 to the power of 7. To the 3 to the power of 5 you need to multiply now again 3 square, that is 3 to the power of 5 into 3 square. 3 power 5 is 243, 3 square is 9. 9 3s are 27, 9 4s are 36, 37 38, 9 2s are 18, 19 20 21. So what is the final answer? 2187 is going to become your final answer. Go through it once. 2187 is going to become your final answer. Okay, go through it, try and understand the question. Okay, let's move on to the next question. Now the next question given over the board is question number 2. 1 mole of ideal monatomic gas is confined by a cylinder by a piston and is maintained at a constant temperature. Constant temperature is saying. By the thermal contact with the heat reservoir, the gas slowly expands from a V1 to V2. Change in internal energy is equals to change in the internal energy. Change in the internal energy means du. What is the formula for du? In the previous video lecture also I have told you the formula is du equal to mcv dt. What is the T here? Temperature. Temperature is what? A constant. Differentiation of constant is equals to 0. That means dt is equals to 0. If dt is equals to 0, then du is also equals to 0. It's a tricky question. So what is the final answer going to become? Du equals to 0. Go through it. This you need to remember from the Joule's law. What does Joule's law states? Joule's law states that internal energy is a function of what? A temperature. Internal energy increases, temperature increases. Internal energy decreases, temperature decreases. Internal energy constant, temperature also constant. Okay. So temperature constant, internal energy constant. Differentiation of constant is equals to 0. So differentiation of internal energy, where internal energy is also what? A constant. So the answer is going to become 0. Okay. Moving on to the question number 3. In an adiabatic expansion of ideal gas, adiabatic expansion is asking. We know in the adiabatic expansion we are having some relation. PV to the power of gamma is equals to constant. TV to the power of gamma minus 1 is equals to constant. P to the power of 1 minus gamma, T to the power of gamma is equals to constant. Okay, among which the third one is important and the third one is here asked question. We know that how this equation is coming, pressure and temperature are directly proportional. Over the pressure we will be having the power as 1 by gamma, over the temperature we will be having the power as 1 by gamma minus 1. Okay. Then what are we going to do? Send this gamma minus 1 to the left hand side. So this will become P power gamma minus 1 and this will become T to the power of gamma. Send this to the denominator, what it will become? T to the power of gamma divided by P to the power of gamma minus 1 is equals to some constant. Send this P to the numerator, what it will become now? P to the power of 1 minus gamma, T to the power of gamma is equals to constant. So this is your final answer. P power 1 minus gamma, T power gamma equal to constant. Already appeared a question and an expected question in the examination too. Okay, go through it. Moving on to the next question, question number 4. Work done by 0.1 mole of a gas. Number of moles is equals to 1. 27 degree it is, 27 degrees Celsius. that is T1 is equals to 27 degrees Celsius, that is 300 Kelvin. To double its volume, that means V1 is equals to V, V2 is equals to 2V. At a constant pressure is remaining constant. When pressure is constant, PV by T is the ideal gas equation, pressure is constant. So we can write V1 by T1 is equals to V2 by T2, where V1 is V, V2 is 2V, T1 is 300, T2 is what? So T2 is going to become 2 times of 300. So T2 is equals to 600 K. Asked question is work done. Work done is equals to constant pressure process P into V2 minus V1, NR T2 minus T1. Number of moles 0.1. R value given in the question 2. T2 value 600, T1 value 300. 600 minus 300, 300. 300 2s are 0.1s. What this will become now? 0.1 and this 0 gets cancelled. 32s are 60. So 60 calories is going to become your correct answer. Go for it. Okay. Work done formula you need to memorize. Work done formula is NR T2 minus T1. Let me give you all the work done formulas at one place. Volume is constant, pressure is constant, temperature constant, heat is a constant. This is isochoric, this one is isobaric, this one is isothermal, and this one is adiabatic, reversible adiabatic, also called as isentropic process. So what is the work done formula? Work done is equals to 0, work done is equals to P into V2 minus V1, that is equals to MR T2 minus T1, that is equals to N into RU, universal gas constant, T2 minus T1. This is characteristic gas constant, this is universal gas constant. Isothermal P1 V1 log V2 divided by V1. Isentropic dW is equals to minus du. Or you can write P1 V1 minus P2 V2 by gamma minus 1 also in this spread problem. All the 4 processes and 4 work done formulas I have given over the board. Moving on to the question number 5. If the pressure of a gas contained in a closed vessel is increased by 0.4%, let's say P1 is equals to P, then P2 is equals to P1 is equals to P, P2 is equals to increased by 0.4%. That means this is 1.004 times of P, because 4% it is small. 4 divided by 100. Okay. 4 divided by 100, 4 into 10 to the power of minus 2, right? Okay. 0.004. If 40 it is, it's going to become what? 0.4. Okay. Then 0.4 percentage. 0.4 divided by 100. So 2 digits more you will be getting. Yes, right. Next one. When it is heated by 1 degree Celsius, it is degree. This is not 1, this is 1, this symbol is degree, 1 degree Celsius. Heated by 1 degree Celsius, so delta T is equals to 1. That means T2 minus T1 is equals to 1. That means T2 is equals to 1 plus T1. Or let's say T1 is equals to what? T. So we can write here T2 is equals to 1 plus T. We know, as is saying in the question, that its initial temperature is what? Closed vessel, he said. Closed vessel means volume is constant. PV by T is constant in the ideal gas. Volume is constant for the closed vessel. So what is the relation now? P1 by T1 is equals to P2 by T2. T2 is what we need to find out. So P1 is equals to P, P2 is equals to 1.004 times of P. T1 is equals to T, T2 is equals to 1 plus T. PP gets cancelled. What is it going to become now? Okay, 1 plus T, cross multiply, 1 plus T into 1 plus T is equals to 1.004 T. Because pressure gets cancelled, this T you need to multiply here now. Send this to the right hand side, this is going to become minus T. So 1 is equals to, this is T taken common, 1.004 minus 1, that means 0.004 you will be getting. Okay? That means T is equals to 1 divided by 0.004. That can be written as 1 divided by 4 into 10 to the power of minus 3. 10 power minus 3 goes to the numerator. 1000 divided by 4. 1000 divided by 4. Okay, what is the 4 ones are? 4 twos are 8. Remaining is what? 2. 4 fives are 20. 250. So this is your answer. 250 degrees Celsius or 250 Kelvin. This is 250 Kelvin is going to become your correct answer. This is your answer. 250 Kelvin. Go through it. With which we have found out the initial temperature value, 250 Kelvin. Okay. Moving on to the next question. A monatomic ideal gas initially at a temperature T1. Initial temperature T1. Fitted with a frictionless piston, the gas is allowed to expand adiabatically. Process is given. Which process it is? Adiabatic. To a temperature what? T2. By releasing the piston suddenly, L1 and L2 are the lengths of the gas column before and after the expansion respectively. Then T1 by T2. We know the relation in between T1 by T2 to volume. Volume is V2 divided by V1. Whole to the power of, volume does not have any power, 1 by 1. This is 1 by gamma minus 1. 1 by gamma minus 1 going to the right hand side, it will become gamma minus 1. He is saying in the question that it is which type of gas? Monoatomic gas. For the monoatomic gas, gamma is equals to 5 divided by 3. Gamma equal to 5 divided by 3. So here will be substituting as area into final length L2, area into initial length L1. Given in the question L1 and L2 values. L1 and L2 values. Area gets cancelled, whole to the power of 5 by 3 minus 1. So this will become L2 divided by L1 whole to the power of 5 minus 3 by 3. 5 minus 3 by 3, this one is 2 by 3. So what is the final answer now? T1 divided by T2 is equals to L2 divided by L1 whole to the power of 2 by 3 is going to become your final answer. Okay. What is the relation between volume, pressure and temperature? Volume is 1 by 2, pressure is 2 by 1, temperature is 2 by 1. Volume power, I am not writing anything. Pressure power 1 by gamma, temperature power 1 by gamma minus 1. That is what we have using here. We want to write like this, T1 divided by T2, we need to write P1 divided by P2, and volume we need to write V2 divided by V1. What is the power? Volume, temperature power 1 by gamma minus 1, pressure power 1 by gamma, volume does not have any power. In this problem we have used these two relations, volume and temperature ratio. Temperature ratio, send this power to the left hand side, 1 by gamma minus 1 will become here gamma minus 1, that is what we have written here. Temperature T1 by T2, T1 by T2, V2 by V1, V2 by V1. Temperature power, that is 1 by gamma minus 1, we are sending it over the volume, then it will become gamma minus 1. That is how we got this answer. Okay. So what is the correct one now? L2 divided by L1 to the power of 2 by 3 is going to become your correct answer. Moving on to the question number 7. An ideal gas at a temperature T is compressed through an isochoric process. Isochoric process means volume is remaining what? Constant. Until its pressure is doubled. P1 is equals to P, P2 is equals to 2P. What is the final temperature when initial temperature is T? T1 is equals to T, T2 is equals to what? From the ideal gas we know PV by T, volume is constant. So what we can write here? P1 by T1 is equals to P2 divided by T2. P1 is P, P2 is 2P. T1 is T, T2 is what? This both gets cancelled. Cross multiply. T2 is equals to 2 times of T. Very simple question. T2 is 2 times of T. 2 times of T is going to become your correct answer. Isochoric. The word isochoric here represents volume is a constant. Volume is a constant. Go through it. Moving on to the next question, question number 8. Okay, here is mentioning about isochoric process, names again. Then mentioned isobaric process, that is pressure constant. Then remain asked the question is isothermal. Fourth one is adiabatic. Okay, I have given you all the 4. Isochoric is given in the option number 4, that is volume is a constant. Isobaric is given in the option number 1, that is pressure remains constant. Pressure is constant. Isothermal is given in the option number 2, that is temperature is constant. Adiabatic is remaining now, that is given in the option number 3, that is the heat is constant. So what is the correct answer? 4, 1, 2, 3. This is going to become the correct answer. 4, 1, 2, 3, which is given in the option number 4. Go through it. Isochoric, volume constant; isobaric, pressure constant; isothermal, temperature constant; and adiabatic, heat constant. Moving on to the question number 9. If the temperature remains constant, the volume of the gas will. Temperature is remaining constant. If temperature is constant, then what is the relation between pressure and volume? Both are inversely proportional to each other. That means the volume of the gas will increase when pressure decreases. Volume increases when pressure decreases. Inversely proportional. Increase with decrease in pressure. Very simple question. If you remember the PV by T relation, easily you can identify for the constant temperature. Moving on to the question number 10. A gas at a pressure 150, pressure is equals to 150, compressed to half of its volume, that means V1 is equals to V, V2 is equals to V by 2, half of the volume. If the expansion is isothermal, constant temperature, final pressure is P2 is equals to what? We know that PV by T, now temperature is constant. So we can write like this: P1 V1 is equals to P2 V2, where P1 is 150, V1 is V, P2 is, we have to find out, V2 is V by 2. V gets cancelled, 2 times of 150. So P2 is equals to 2 into 150. 2 into 150, 300 Newton per meter square. So this is going to become your correct answer. Go through it. Moving on to the question number 11. Which of the following statement is correct in the case of isothermal process? What is the meaning of isothermal? Temperature is constant, internal energy is constant, change in temperature is equals to 0, change in internal energy is equals to 0. This process is very slow process. Heat transfer will convert it into what? Work transfer. Okay. Temperature changes? No, temperature is constant. So that's why this statement is wrong. Exchange of heat takes place between gas and surrounding? Yes, heat transfer will take place. Boyle's law does not valid? No, Boyle's law is valid. What is Boyle's law? Boyle's law states that temperature is remaining what? Constant. Pressure is inversely proportional to volume. So Boyle's law is valid. He is saying not valid, so that's why it is wrong. It is a quick process. Quick process is wrong because isothermal is a slow. Isothermal is a slow process. Go through it. Now we know all the conditions of isothermal. Question number 12. For an adiabatic expansion of an ideal gas, the fractional change in the pressure is equals to. For that you need to remember the slopes. Easily we can understand. First one is volume constant process. Second one is pressure constant process. Third one is temperature constant process. And fourth one is heat constant process. What is the formula for slope? Slope is equals to dP divided by dV. dP divided by dV is equals to minus n P by V. N value is equals to, or volume constant, infinity, pressure constant, 0, temperature constant, n is equals to 1, heat constant, n is equals to gamma. Now substitute here. So dP by dV for constant volume process is equals to infinity. dP by dV for constant pressure process is equals to 0. dP by dV for constant temperature is minus P by V because n value is 1. dP by dV is equals to minus gamma P by V. This is what we require, minus gamma P by V. He is asking the relation for adiabatic expansion, ideal gas, fractional change in pressure. Fractional change in pressure means dP by P. So dP by P is called as what? A fractional change in pressure. Fractional change in pressure is dP by P. dP by P is equals to minus gamma dV by V. So what is your answer now? Minus gamma dV by V. All the slopes I have given at one place. Constant volume, constant pressure, constant temperature, heat constant. N value is also given, infinity, 0, 1, gamma. Slope general formula, minus n P by V. N is infinity, infinity, n is 0, 0, n is 1, minus P by V, n by is gamma, minus gamma, P by V is your answer. Okay. Moving on to the next question, question number 13. An ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of original volume. V1 is equals to V, V2 is equals to 8 by 27 times of V. Gamma is 5 by 3, then rise in temperature is equals to delta T is equals to rise in temperature T2 minus T1. Okay. We know the relation in between temperature T2 divided by T1 is equals to, in terms of volume, V1 divided by V2 whole to the power of gamma minus 1. Let's say V1 is equals to V, V2 is equals to 8 by 27 times of V. So V gets cancelled. Gamma value given in the question 5 by 3. So this is 5 by 3 minus 1. What it will become now? 27 divided by 8 whole to the power of 5 minus 3 by 3, that is 2 by 3. Now we can write like this. This is 3 3s are 9, 9 3s are 27. This is 2 2s are 4, 4 2s are 8 whole to the power of 2 by 3. So this is going to become 3 by 2 cube whole to the power of 2 by 3. 3 3 gets cancelled. 3 3s are 9, 2 2s are 4. So this is 9 divided by 4. T2 by T1. T2 by T1 is equals to 9 divided by 4. That means T2 is equals to 9 by 4 times of T1. 9 by 4 times of T1. Then T1 is equals to 300 Kelvin. So T2 is equals to 9 by 4 times of 300. Right? So this is 4 1s are 4 1s are 4 6s are 24. 4 6s are 24. Remaining is 4 4s are 16. 4 5s are 20. 4 6s are 24. 4 7s are 28. So we can write here 7s are 28, 29, 30, 2 remaining, 4 5s are 20. So 75 times of 9. 5 8s are 40, 5 9s are 45, 9 7s are 63, 63 plus 4, 67, 675. So now we got the T2 is equals to 675 Kelvin and T1 is equals to around 300 Kelvin. So the remaining answer for delta T, that is rise in temperature, that is 375 Kelvin. 375 Kelvin is going to become your right answer. Asked question is rise in temperature. Rise in temperature means delta T. Delta T is T2 minus T1. T2 minus T1, that is 675 minus 300. It is going to become 375. Go through it. Pause the video, note it down. Moving on to the next question. Question number 14. The temperature of moles of a gas increased from T to 40 through a process of which pressure indicates P is equals to 80 to the power of minus 1, or P is equals to, we can say P is equals to A by T. P is equals to A by T. Given in the question, temperature of a moles of an ideal gas is increased from T to 40 through a process of P is equals to 80 to the power of minus 1. Generally we know that PV is equals to N into RU into T, nRT. Okay. Now P is a function of water temperature. We know that the formula for V going to become water nRT divided by water P. nRT divided by P. So P can be written as water. P can be written as A by T. A divided by T. So this is going to become water T square. Then dV going to become differentiation of V, differentiation of temperature, because R is a constant, A is a constant, N is a constant. So this is going to become water nR by A differentiation of T square. Okay, differentiation of T square. What is the differentiation of T square going to become? 2T dt. So this is going to become 2nR T, because 2T dt divided by water A. This is dV. Asked the question is work done. Work done is equals to integral of P dV. So integral within a limit of temperature T to 40. P is what? A by T. dV is what? dV. dV is 2nRT dt divided by A. A cancel, T cancel. Integration of 1 dt is T within a limit of 4t minus T, that is 3t. So this is going to become 2nR, integration of 1 dt is T within a limit of what? T and 4t. So 4t minus T, upper limit minus lower limit, 2nR 4t minus T, that is 3t. So 2nR 3t, 3 2s are 6, 6nRT is going to become your correct answer. This is the correct answer. Go through it. Work done formula you need to know. Work done formula is integral of P dV. P is given, dV we have got the answer from the ideal gas equation. Pause the video, note it down. Moving on to the next question. The next question given over the board is when an ideal gas with pressure P, volume V compressed isothermally to P1 is equals to P, V1 is equals to V, compressed isothermally, temperature is what? Constant, to 1/4 of its volume, that is V2 is equals to V divided by 4, and the pressure is P1, and the pressure is P1, that is P2 is saying that P1. When the same gas is compressed polytropically according to the equation PV to the power of 1.5 constant to 1/4 of its initial volume, 1/4 of its initial volume. Let's say here V1 is equals to V, V2 is equals to also V divided by 4, and the pressure is, final pressure is P2, final pressure is what? P2 here. The ratio of P2 by P1, this ratio by this ratio is asking. First of all, he said that this is which process? Isothermal process. Isothermal. Now here he is saying that it is polytropic process. Isothermal process is what? Let me write first of all this equation. P1 V1 is equals to P2 V2, where P1 is equals to P, V1 is equals to V, P2 is equals to P dash V1, let's say, and V2 is equals to V by 4. So these two gets cancelled. That means P1 is equals to what now? 4P. P1 is equals to 4P. So this is the P1. Now polytropic condition is what? P2 divided by P1 is equals to V1 divided by V2 whole to the power of gamma, or n we can say, and value is given as what? 1.5. So here he is saying P2 is what? P2 only. P1 is equals to, let's say it is P. V1 is equals to V, V2 is equals to V divided by 4 whole to the power of 1.5, 1.5 is 3 by 2. V gets cancelled, this is going to become 4 to the power of 3 by 2, that is 2 square to the power of 3 by 2, 2 gets cancelled, 2 to the 4, 4 to the 8. So here P2 is equals to 8P. What is the P1? 4P, P2 8P. Asked the question is P2 by P1. So P2 divided by P1 is equals to 8P divided by 4P, PP cancel, 8 by 4, 4 1 the 4 2 the. What is the final answer now? 2. 2 is going to become your final answer. Go through it. Very interesting question and important too. Moving on to the question number 15. Two identical samples of gas are allowed and isothermally and adiabatically work done is. This is a generalized question. Work done. This is pressure versus volume. This is n value is equals to 0. Here n value is equals to infinity. This is n value is equals to 1, and this one is n value is equals to gamma. Gamma is equals to 1.4. If we are going to plot these two areas, okay na? 1.4 and this is 1. One comparison we will be finding out this area. This is n is equals to 1. This area will be what? More. This area would be what? More. N value is equals to 1. This is n value equals to 1.4. So the area of isothermal will be greater than area of adiabatic. Area of isothermal is greater than area of adiabatic. And area represents what? Work done. So work done in isothermal will be greater than work done in adiabatic process. Go through it. Expand. Isothermally, second one is adiabatically. So work done is more in which process? Isothermal process. Work done is more in a isothermal process. Go through it. Next one. Question number 70. The volume of a gas at a constant pressure is constant pressure of 103 Newton per meter square expands by dV is equals to 0.25. Work done is equals to work done is PdV. Work done is a PdV, where P into V2 minus V1, change in volume. Pressure is around 100, and the volume is around 0.25. So this is, I guess this is 25 divided by what, 100, and this is not 100, this is 10 cube. This is 10 cube. If this is 10 cube, that means it is 1000. So 0, 0, 0, 0 gets cancelled, and this is 250 joules. 250 joules is the correct answer. Go through it. It's 10 cube. 1000. Okay. Moving on to the next question. For an adiabatic expansion of perfect gas, the value of delta P by P. Repeated question. Already we have seen. dP divided by dV is equals to minus n P by V. dP divided by dV is equals to infinity 0 minus P by V minus gamma P by V. This is for volume constant process, this is for pressure constant process, this is for temperature constant process, this is for heat constant process. So now we got the answer as heat constant dP by dV is equals to dP by dV is equals to minus gamma P by V, where we can write dP by P is equals to, pressure is going in the down, so it is going to move up, so this is minus gamma dV divided by V. Repeated question. Minus gamma delta V by V going to become your correct answer. Moving on to the question number 19. An ideal diatomic gas is heated at constant pressure. The fraction of the heat energy supplied to increase the internal energy of the gases. Fraction of the heat energy is applied to increase the internal energy. We know the formula for ideal diatomic gas at constant pressure. This formula is m into Cv into dt. Constant pressure, this is m into Cp into dt. dt mm gets cancelled. Cv by Cp. Cv divided by Cp is 1 divided by gamma. And gamma for diatomic gas, it is 7 by 5. 7 divided by 5. So 1 by gamma is going to become what? 5 divided by 7. So this is the ECET 2024 asked question. Okay, fraction of heat energy utilized for internal energy. Moving on to the next question. Now this is match the following question. Given is adiabatic process. Second one is B1 is isochoric process. C1 is isobaric. Names is asking now. And the last one is isothermal. Mentioning these are A, B, C and D. 1, 2, 3, 4. Options are given as volume does not change, no volume changes, that means volume is constant. Second one is pressure is constant. Third one is temperature constant. Fourth one is heat is constant. Now match this. We know that adiabatic is what? Heat constant. Isochoric is volume constant. Isobaric is pressure constant. Isothermal is temperature constant. That means A is going to become what? 4. B is going to become 1. C is going to become 2. D is going to become 3. So the answer is 4, 1, 2, 3. 4, 1, 2, 3. 4, 1, 2, 3 is given in the option number 3. So this is going to become your correct answer. Go for it. Pause the video, note it down. Now let's move on with some important questions for the thermodynamic processes part 2. Question number 1, important question, an expected question in the examination. A thermodynamic energy goes from P1 to P1, V to V only. That means it is a constant volume process. constant volume process. Like P1 V changed to 2V, that means this is constant pressure process. Constant pressure process. Asked question is, what is the work done in these two? It is a closed system. We know that constant volume work done formula is P into V2 minus V1, where V is constant. V is constant. So P into, this is V minus V, that is equals to 0. So work done is equals to 0. Whereas, what is the work done in the second constant pressure process? What is the formula? P into V2 minus V1. Where pressure is P1, V2 is 2V, V1 is V. V2, V1, 2V minus V. 2V minus V, it is V. So this is P1V. So this is second work done. First work done is 0. Second work done is P1V. So what is the correct answer now? 0 and P1V is the correct answer, which is given in the option number 2. Expected question in the examination. Moving on to the second important question. An adiabatic process occurs at, we know, isochoric process, isobaric process, isothermal process, and adiabatic. One more is there, that is called as polytropic process. Adiabatic is also called as isentropic. Okay, reversible adiabatic is called as isentropic. Isochoric, volume is constant. Isobaric, pressure is constant. Isothermal, temperature is constant. Adiabatic, heat is constant. Polytropic, this is general law of expansion. PV to the power of n is equals to constant. Like, so heat is constant is given in which process? Adiabatic process. Adiabatic process occurs at constant dash. What is the correct answer? Heat is going to become your correct answer. Go through it once. Moving on to the question number 3. The pressure temperature relationship for ideal gas. I have given in adiabatic process. Adiabatic process, you are having standard relation PV power gamma equal to constant, TV power gamma minus 1 is equals to constant, P to the power of 1 minus gamma, T to the power of gamma is equals to constant. Okay. I have given this as relation in this manner, that is P2 by P1 whole to the power of 1 by gamma is equals to T2 by T1 whole to the power of 1 by gamma minus 1. Send this gamma minus 1 to the left hand side, this is pressure power gamma minus 1, directly proportional to temperature. 1 by gamma sent to the right hand side, this is gamma. Send it to the denominator, then what it will become? T power gamma divided by P to the power of gamma minus 1 is equals to constant. Send this denominator to numerator, it will become minus 1 plus gamma, minus of gamma minus 1, minus of gamma minus 1 will become what? 1 minus gamma. So this is 1 minus gamma, T to the power of gamma is equals to constant. So what is the correct answer now? Option number 1. Other T's also I have given over the board. P power gamma, PV power gamma equal to constant, TV power gamma minus 1 is equals to constant. Go through it. Moving on to the fourth important question. The work done in adiabatic changes, particularly gas, depends only on. This is most expected question. Most expected question. Remember this one, very important. We know that heat transfer is equals to internal energy plus work transfer. Adiabatic process, heat is constant, so constant differentiation equals to 0. We know that work done is equals to minus du. We did it in the PYQs too. And his work is depending upon what? Internal energy. Work is depending upon what? Internal energy. Now internal energy according to Joule's law, this is multiple times ECET appeared question. Internal energy according to Joule's law is a function of what? Temperature. Is a function of a temperature. That means internal energy increases with the increase in temperature. Internal energy decreases with decrease in temperature. Internal energy is constant, then temperature is also constant. That means work of adiabatic is depending on internal energy change, and internal energy is depending upon change in temperature. So what is the correct answer going to become now? Work done is dependent on change in temperature. Very important question, remember it. Moving on to the final question, question number 5. Slope of isothermal and adiabatic curve are related as. I have given all the slopes. Okay, what is the slope of isothermal? Slope of isothermal, dP by dV is equals to minus P by V. Whereas slope of adiabatic is equals to dP by dV is equals to minus gamma P by V. Now we can say that minus P by V is slope of what? Isothermal. So I can write slope of adiabatic is equals to gamma times of minus P by V, where minus P by V is the slope of what? Isothermal. Slope of isothermal. Very important question. This is also MEQ, most expected question in the examination. So what is the correct answer now? Adiabatic curve slope is how many times isothermal curve slope? It is gamma times. Okay, adiabatic slope curve is gamma times the isothermal curve slope. Go through it. Chalo. Pause the video and note it down.